Good afternoon, everybody. So thank you so much for joining us at today's Lunch and Learn. That's going to give you a sneak peek of the results of DIAS's recent machine learning survey across Australia and New Zealand. My name is Kirsty Miller, and I'm DIAS's Head of Strategy and Growth. I'll be presenting today along with Mark Foa, who is DIAS's Client Engagement Principal for Machine Learning and Practice Lead, and also Nigel Hook, who is our DIAS Machine Learning Technical Lead. Before we get started, and in the spirit of a reconciliation, DIAS acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islanders people today. So today we'll be covering the following focus areas. So I'll be starting off by sharing some survey results on ML adoption in Australia and New Zealand and how organisations are applying machine learning to derive business benefit. Then I'm going to pass over to Nigel, who will share some results into how machine learning tools, techniques and platforms are being used. And finally, we'll end with Mark. Thank you, Mark, sharing some case studies on how organisations are using machine learning to help us bring the survey results to life. And then also shares some advice for success with machine learning directly from some of the respondents from the organisations that we spoke with. So this is a presentation today, but we do welcome your questions at any time. So you can ask them using Slido, and we've got the code there. And perhaps Chris or Erin, you'd be so kind, or Angela, to pop that Slido link into the chat. Or you can go ahead and use the Google question and answer feature. So if you go to the activities on the bottom right-hand corner, if you're not familiar, it's the triangle with the square and the circle. If you click in there, you'll see a QA feature. And yeah, please feel free to answer questions. We'll either answer them as we go or we'll answer them at the end. Thank you, Angela, for sharing that. So for those of us who are new to DIAS, I don't think many of you are, however. So we're a technology consulting company that helps our customers innovate and grow. This covers data, digital and devices, and the convergence between all three. We have a very broad capability and solution set, which we use to problem solve for a diverse range of customers. And one of these solution sets is machine learning. We've had a machine learning specialist speciality within DIAS for the past 6 years. So here at DIAS, we believe machine learning is going to define the future of technology in many ways. So accordingly, we have invested in this specialist area to help take organizations forward in this emerging area. So for us here at DIAS, it's not about the technology itself. It's about how machine learning is going to change what's possible. And then also its influence on how we, I guess, develop and interact with products. It's going to create a lot of changes. So we've been talking through our practice and through our consulting services to many organizations about how to best leverage machine learning over the past 6 years. And I guess what we found is that, most organizations have this really strong interest in machine learning, but there's not, I guess, adoption at the rate that we think it should be for machine learning. So we have our own view, obviously, on what the blockers are and what's holding organizations back. But we decided to, I guess, really, be evidence-based and gather more information about what our hypotheses were with some market data. So last year, you can see here the front cover of the machine learning report in Australia. This was the first time that we did it, and we brought together the results from about 200 survey responses from across Australia. We received some really interesting and insightful results that really helped inform our thoughts. So this year we went out again during the latter half of this year to understand what, if anything, had changed. We added a new geographic region, which is New Zealand. And then we also added a couple of new questions to further inform our thinking. And we were really pleased to receive nearly 400 results this time, so almost double last year. So what did we find? So let's start with one of the things that everybody always asks us about. What is the adoption rate? Who is actually doing it? How many people are actually doing it? We get questions from organizations that haven't yet started their machine learning journey. And they often, I guess, are quite skeptical about who's actually doing it. So when we look at machine learning, we look at it, machine learning adoption as a journey, and categorize cohorts according to where they are on the stage. So we've defined the start of the machine learning journey as the consideration stage, where a business is focused on prioritizing and selecting the most promising use cases for a machine learning initiative. And adoption is where organizations have initiatives either in proof of concept or in production. So firstly, if we look at the results from the most recent survey, we have 15% of the respondents have not started. Organizations that have identified a problem to focus on at the considering stage, 30%. And 32% are experimenting, and 23% are applying. The 23% are those organizations that are in the cohort that has the models in production. So if you roll this up to perhaps make it a bit more meaningful, we say 85%, so those in the considering, experimenting, and applying stages, have started their machine learning journey. And those that are hands-on, those are the adopters. So 55% have adopted machine learning. So there's no surprise that this is a really strong result. I'm not sure if those of you who are sitting on the call, this was expected for you or not, but definitely what we can take away from this is that there's a really strong amount of interest in machine learning, as evidenced by the sheer fact that 85% have started their machine learning journey. And strong interest is also signaled through another data point from our survey. 85% of respondents, when we asked them how they viewed machine learning in the future, 85% said it was an important part of future success. So you can see that, the survey is showing that there is this very, very strong interest in machine learning within Australia and New Zealand. Another thing that people are very interested in is what is the difference between Australia and New Zealand? And in fact, that was something that we asked ourselves last year, and that was why we decided to go out and include New Zealand as an additional geographic area in our survey this time. Now, we did wonder whether or not New Zealand would be a little bit behind Australia. I guess we've had quite a bit of anecdotal evidence through our consulting practice that machine learning skills shortage is, I guess, higher in New Zealand than it is in Australia. I mean, of course, as we all know, machine learning skills are scarce everywhere. I think we just have to read all the stories in the media. So we thought, okay, well, let's take a look at the data and look at the actual adoption rates. And if you have a look at these two, there are some small differences, some small discrepancies, but really there's not a massive discrepancy. So New Zealand, 81% have started their machine learning journey, 53% have adopted machine learning. In Australia, 85% have started a machine learning journey and 55% have adopted. So, sure, I guess you could say there's slightly less in New Zealand that have started the machine journey, but I'd say that the results are quite comparable. Now, the other key question that we wanted to know is what was the difference between last year and this year? And, was machine learning adoption accelerating? And I think if you look at this bar chart, which clearly shows where organizations, the cohorts of organizations in the different stages, the difference between 21 and 22 is really not that much. There's really not been that much change at all. In fact, because of the sample sizes, which albeit, we did have a larger one this year, I think probably you can't call this result significant at all. So last year we had 82% starting a machine learning journey with 54% adoption. This year we have 85% starting a machine learning journey with 55% adoption. So, you know, was this an expected result? Did we expect more movement? We did. We really did expect more movement from the previous year. I think when we looked at the data and the signals that we were getting from the 2021 survey, we did predict machine learning adoption would accelerate. And this was because of the evidence that was presented in the survey, as well as the fact that we did have strong demand for our machine learning consulting services throughout the year. So what led us to expect this acceleration? Well, last year, we had this strong interest in machine learning. 8 out of 10 organizations had started a machine learning journey, and 54% had adopted machine learning. Quite strong. I mentioned before, when we asked respondents about how they regarded machine learning's importance in their future business success, this year, 85% of people said that it was critical or one of several important technologies going forward. Last year, 86% said that. And there was strong evidence that people who had not started had planned to do so. So of the people that were in that not started cohort who hadn't done anything at all with machine learning, just about half of them said, I haven't started, but we are going to do so in the next 1 to 2 years. So we thought that that was pretty strong evidence that it was going to accelerate, but it did not. And I think, when we got this result, we really took a little dive into the survey data to see if we could find any anomalies. I'm happy to say no. I mean, of course, the sample size could be one factor. And then we also asked ourselves, like, were we asking the same people that we asked last year and maybe they just hadn't moved forward? That is not the case. We confirmed that. So we also had a look around at other survey results. And I guess one we can point to that found exactly the same result as we did is the O'Reilly State of Machine Learning report that they release every year. They too compared last year and this year, and they found no movement, no adoption. They've posited that this is because machine learning has reached a particular point in the hype cycle. I don't actually agree with that. And it is just a hypothesis of theirs, but I think that if we go forward and talk about the challenges as to why we haven't seen acceleration, I hope that you will all agree with me that there is more growth in the market still, and people are still working through their machine learning journeys. So what are the reasons why more people didn't progress their machine learning journeys, or they perhaps didn't start a machine learning journey when they planned to? So when we look at the questions and the data from the survey, there's actually a combination of factors. One of them is we deliberately asked organizations this year on how COVID-19 had impacted their plans or their machine learning priorities. And 53%, just over half of the sample, said that COVID-19 had delayed their implementation of machine learning. And while we didn't ask this specifically, I would have to say you would also throw in the impact of the economic headwinds that we've all experienced recently. We know certainly that that is going to slow decision-making and make people take a longer time to evaluate starting anything new or making a change. Another factor that always impacts machine learning adoption, or indeed, I guess, progression within the machine learning journey, and in fact, actually success with machine learning, is the amount of internal machine learning capability that organizations have. And this is obviously one of the questions we asked. And over half the respondents in this survey had none or limited internal machine learning capability. So while we can't make a direct correlation, definitely I feel like that's one of the factors that has impacted people progressing their machine learning journeys or even starting. And then lastly, we asked people up and over and above the COVID-19 impact, we asked people about their challenges, and I'm going to dive a bit into those in the coming slides, like what particular challenges are organizations facing. But if you look at them across the different stages of the machine learning journey for those organizations that have started, you know, ranging from 49% to 69% said, yes, you know, all the challenges we are experiencing are impacting our success or our adoption of machine learning. And I guess, you know, another key point to call out here is even when you're mature, even when you're in the applying stage, you're still experiencing challenges. Even mature machine learning organizations are continuing to face challenges. And I guess really, you know, in our work with clients, we do find that organizations continue to underestimate the complexity, the range of skill roles, and I guess the changes that you need to make to do machine learning well. In terms of challenges, what we've always found is the challenges that affect your adoption of machine learning differ by what stage you are at, like what mature. You have completely, or you have different considerations depending on what you're focused on. So if we asked people about their challenges, and we've just presented the top 3 here, if you're experimenting, you can see that there are actually lack of machine knowledge and skills in-house. You know, not being able to define a proof of concept or a pilot can be a challenge, and then also data related. With this question, people were allowed to select more than one option. And I guess the other thing that this question shows, or the answers to this question shows, that it's never just one challenge. It's always a combination. So it's not useful, I think, to look at these results and look for a single silver bullet that organizations should focus on to help move them forward. It's always a multifactorial thing. If you look at the applying stage, we actually split these results for this question so that we could dive a little bit deeper. We wanted to look at organizations that were getting ready to put into production, and then organizations that were very mature, had one or more machine learning models. Now, there's a lot of data on here, but I guess really what we can take away from this is that, again, a reminder that it's not just one thing. And then also, too, you see data related appear in the top 3 challenges, regardless of what stage you're at. Data is one of the biggest, I guess, factors in getting machine learning right. We come up against it time and time again, and it remains to be one of the biggest challenges organizations face when they do machine learning. Yes, this is my favorite part, and the most interesting thing that I actually think that we found this year in the machine learning survey. So last year, we looked at how organizations were applying machine learning. In what areas of the business were people deriving value? And in 2021, we found the top machine learning use cases were internally focused. And by that, I mean the top 2 use cases were internal efficiency and business decision-making. And then from all the data that was presented, we came up with a key finding, and we said, we think in 2022, respondents are going to shift to having a focus, not just on internal focus, but they're going to have a dual focus on internal and external. And we were really pleased to find out that that is actually true. So I'll run through these results in detail with you. So the 2 top use cases were customer experience and support. And I've included there on the slide some examples of how these actually manifest in the business. So customer experience and support, those are things like chatbot, churn prediction, personalization, search ranking, and operational efficiency is workflow augmentation. I guess another thing to add here when we're looking at the difference between last year and this year is I don't know whether or not you saw my lightning quick change between the slides. The top two use cases were in the 40s, and these are in the 70s and the 60s. Both questions for both years were multi-select, which leads us to, the finding that most organizations are applying it in more than one area, but the distribution and the actual frequency increased so much more this year. So it seems like more organizations are doing more. How shall I say it? More than one, more than two, more than three, and then a greater proportion are actually focused on these two use cases. 54% is on sales and marketing. That's where organizations do targeted customer segmentation. Security, fraud, and compliance, so 46%. Now, this doesn't just include things like identity fraud. It's also things like virtual proctoring, and then also looking for patterns in customer transactions. Business decision-making, 38%. A reminder that that was the second most popular last time. Decision support, demand forecasting, and risk assessment. Manufacturing and quality control, 29%. And then lastly, occupational health and safety at 27%. So I guess the question that we have to answer before I hand off to Nigel is whether or not we think machine learning adoption is going to increase. So that was one of the key questions we had last year. Obviously, it hasn't really materially increased for the reasons that I've posited so far in this presentation. I have to give it's unclear answer. So there are some data points which I'll share with you shortly, which indicate that it's likely to, but they are the same signals that we received loud and clear from last year. So we don't know whether or not this interest in machine learning will actually translate into adoption. You can't be sure. And I guess another factor is that, machine learning can have such a strong impact on workflow augmentation, cost cutting, but also in products that generate revenue. So, the shift in business drivers that we've seen from 21 to 22, really it goes to show that people are focusing on automation and, driving internal efficiencies through looking at, how processes are done and using machine learning to streamline things. But they're also looking at how they can look externally and generate revenue using machine learning. And we've also found that it extends into the use of machine learning to actually create value within a product and be part of what we call a machine learning powered product. We're starting to see more and more of those in the market where the actual value that's delivered to the user is created through machine learning. So we feel like this is something that's too great to ignore, given, perhaps some of the economic headwinds we're facing. Organizations should be focusing on this particular area because of the opportunity that it provides. However, again, we have this really strong signal through the future interest. But one of the things that I would say is that less people who have not started are going to said that they are going to start in the next 1 to 2 years. So I don't know. It's a bit unclear, but I guess it remains to be seen. So now I'm going to stop sharing and I'm going to hand over to my colleague, Nigel Hook.
Thank you, Kirsty. Hello. We wanted to know from a technical perspective what organisations are doing with machine learning. And in the slide title here, by ML domains and techniques, we're referring to the combination of data domains and techniques that distinguish the various algorithmic approaches to ML modelling. And for those respondents who indicated they were either experimenting with or applying ML, we asked about the domains and techniques and allowing them to select one or more. The most popular response was natural language processing, or NLP. This is an area that's undergone a revolutionary change in recent years due to pre-trained language models, which have really boosted accuracy and enabled realistic text generation. As a percentage in our surveys, the NLP popularity hasn't changed significantly since our previous survey, but the previous front runners in front of it have declined in their share, and NLP has held its popularity. We see NLP used increasingly in applications such as intelligent document processing, question and answer systems, etc., and especially in the financial and legal sectors. It has growing support in the form of machine learning as a service offered by cloud providers such as Azure Cognitive Service for Language or Amazon Comprehend. The second most popular was recommendation systems, and this is a stalwart of ML techniques and fairly mature. In the previous survey, this category was the front runner, but it's fallen slightly in popularity. Nevertheless, we continue to see demand for it in the form of personalization for customer-facing applications, and it's offered as a service by products like Google Recommendations AI and Amazon Personalize. The third one was a grouping of clustering, regression, and classification on tabular data. And this group are all stalwarts of ML techniques and pretty mature. They have fallen in popularity rankings since our previous survey, but they nevertheless continue to be popular. We see them frequently used as fairly quick exploratory techniques, sometimes as part of a larger or more complex solution. And they're well supported by cloud vendors with AutoML assistance. Coming in fourth place was computer vision, and this technology is maturing quickly and experiencing a steady uptake. It's dropped slightly in popularity since our previous survey, but in terms of our consulting practice, we continue to see demand from our clients in both customer-facing applications as well as applications supporting operational efficiency. Next place was conversational interfaces. This includes chatbots and other applications offering voice or text-based human-computer interaction. These have fallen in popularity since our previous survey, probably because the technology still isn't able to offer realistic conversation and it's relatively immature. We note that the success of this really is tied to the maturity of natural language processing. So we would expect this to pick up in the future as NLP gains in capability. And the last category we asked about, time series forecasting, is a new category that we didn't use in our previous survey. In our work, we're seeing a growing use of machine learning in this domain, and it's displacing older, more classical techniques. Now, we also wanted to know more about how organisations are building their machine learning models. So we asked those respondents who had indicated they were already starting to explore or applying ML, what they're doing, and respondents could select more than one option. The first option we offered them was machine learning as a service, and by this we're referring to the cognitive APIs provided by cloud vendors. These tend to perform complete machine learning functions like documentation, classification, image object recognition, etc., without requiring training or customization. This is really a great option for a proof of concept or for an organisation that's new to machine learning. But often these techniques are not the ideal fit for a problem. The next option we offered people to select was AutoML assistance, and these are AI ML services provided by cloud vendors that automate ML lifecycle tasks like feature selection, model selection, and training for a data set. And AutoML really offers a much wider range of options than ML as a service. And you can see here it's got significantly higher popularity than ML as a service. Finally, we were curious to see how many organizations were building custom models. And these require the user to select and train their own models. The user has to have quite extensive expertise with machine learning. They have to develop and then manage the models themselves. And you can see here, correspondingly, there's less uptake with this. But these really give the peak performance for organizations that go down this path. Remember, these were options where users could respond to more than one category, but looking more closely, we noticed that 2/3 of the respondents selected only one of these three approaches. And it turns out that in terms of those one and only choices, they also reflected the proportions you see here, the relative proportions. So AutoML is the clear winner out of these choices. Another aspect of an organization's approach to building machine learning models is whether or not they build upon a commercial data science or ML ops platform. So we asked about this again from the same group of respondents who were already experimenting or applying, and we found that over 60% of respondents were using such a platform, and this number is quite striking, and it suggests that the popularity of these platforms indicates they're a significant factor in the adoption of machine learning. Speaking about the work that we do at DS for a moment, we use an MLOps platform for about 80% of our work, and supporting both experimentation in proof of concept, but also productionizing applications for clients. And we really do see the use of such platforms as an enabler, simplifying data sharing amongst teams, standardizing how teams work, supporting automation of the workflow, helping with model management, providing tools for monitoring applications. Excuse me. Pardon. And, oh, I beg your pardon. Excuse me. And in general, these tools, these platforms, simplify the path to production for organizations. So, yeah, we found that result really quite interesting. Now, Kirsty has already talked about the fact that 54% of respondents reported a lack of in-house machine learning skills. In fact, 5% reported having no skills and 49% said they had limited skills. We asked respondents specifically which kinds of skills they were lacking, allowing them to select from more than one option. And what we found was really a broad-based response indicating that there were gaps in multiple areas of skill. This helps explain why the use of commercial data science and ML platforms is so popular in our view. These platforms provide a structure and guidance for working with data, building ML models and putting them into production. And this helps to compensate for the lack of ML skills in an organisation. Just going to hand over now to my colleague Mark Foer for the next stage of the production presentation.
Thanks, Nigel. And I'll just
Thanks.
share my screen in a moment, and hopefully we can see that. In this section, we share some insights into three organisations who are a little further down their journey. So they're either experimenting with machine learning or have solutions already in production. The first is Sealy. Sealy International, I should say, Australia's largest air conditioning and ducted gas heating manufacturer. You might know them through their brands such as Breeze Air and Bramer. They're currently in the experimentation phase. We then have Swoop Aero, a drone logistics startup based out of Melbourne, who deliver medical and essential supplies to some of the most remote locations all over the world. They have a computer vision model in production and are working on others as they diversify their services. And then there's Baltic as the third, a large insurtech who uses machine learning quite extensively across different lines of business within their organisation and different departments. They're the most mature out of the three case studies here, with multiple models in production and quite a well-established data science and machine learning team. Nigel just covered ML skills gap. Now, all three reported some level of skill gap in their organisation, requiring them to engage in some external assistance, however, for different reasons. Sealy, being relatively early in the journey here, in the hands-on experience, I should say, currently have no internal machine learning capability, so they rely almost exclusively on partnering with external organisations. Swoop Aero have some internal capability. However, they're combining machine learning with IoT, which is still a relatively new and emerging area. And Baltic, again, who have their own team, engage external agencies because they have more ideas than they've got the capacity to execute on. So in their situation, it's as much a capacity issue as it is a capability gap. Now, in terms of ML solutions, interestingly, all three are building their own custom models, primarily because the problems they're trying to solve, certainly in some parts of their organisation, can't be solved with pre-built ML services. In the case of Baltic, they continue to use a combination of pre-built services, auto ML as Nigel described, and also custom models, depending on the problem they're solving. And this ability to choose the right tool for the right problem is a sign of maturity and is something other organisations can look forward to developing with a little bit more experience down the track. Now, for a little bit more about each of these companies. So what drove Sealy to start exploring machine learning? Speaking to Barry Earle, R&D project manager, they found that their product and technology was becoming increasingly more complex, and using traditional algorithms and rule-based approaches wasn't giving them the results they were seeking. They'd also made quite a significant investment in cloud and IoT, so they were collecting more data than ever. So they wanted to leverage that data to drive as much value to the business as possible. So how are they using machine learning? One of these areas is reducing the number of service callouts and warranty claims, which obviously impacts their overall profitability. Those service calls can result from sensors degrading over time, so understanding the rate of deterioration is useful for them. Those service callouts themselves are primarily handled by external contractors, so they're also looking at ways to prevent and detect and prevent, I should say, fraud in the process. And beyond the service and warranty side of things, Sealy's also trying to maximize the performance of its cooling systems in order to provide the best product possible for its customers. They're experimenting with automatically optimizing their systems depending on the situation. For example, ensuring optimal temperature, comfort, ventilation at schools, and being able to do this whilst balancing energy usage. Now, in terms of challenges, speaking of Barry, one of the biggest challenges impacting their adoption of machine learning across their business is general awareness of machine learning itself and what it's good at. Whilst they're running POCs in R&D and engineering teams, they can certainly benefit from greater collaboration across the board. The internal ML skills gap we mentioned earlier also contributes to that. And they've certainly already experienced some hurdles productionizing and commercializing some of those ideas. And lastly, although they're collecting more and more data than ever, there isn't a formal data strategy in place just yet. Data storage is still quite siloed, and there have been some challenges with data access and having the appropriate data for model training. Barry's advice to organisations who might be at the same stage or facing similar problems is to attend industry conferences as much as possible, to learn about case studies and success stories, and to connect with your peers for inspiration. As a passionate engineer and technologist himself, Barry often describes himself feeling like a kid in a candy store when he goes to some of these events, and really excited by the tools being used out there. But whilst you might be inspired, think big, but start small. Identify a path with the smallest amount of investment to validate your ideas, and showcase those results and learnings to build awareness and buy-in across the business. And lastly, engage experts to support you and your teams through the journey, especially early on, and build an internal capability once you know what that might look like, and only once your organisation needs it. Moving on to Swoop Aero, as we mentioned earlier, they have autonomous drones flying in some of the most remote and hard to reach places all over the world, including Africa, the UK and regional Australia, and it's all remotely piloted from Port Melbourne. They wanted to explore machine learning because they wanted to scale their operations safely and securely without needing to scale their workforce at the same rate. They were already collecting a lot of data in the form of autopilot logs, not only because they were required to do so to satisfy aviation authorities, but also to optimize drone performance and design. And like Sealy, they wanted to unlock as much value as possible from the data they were collecting. So how's Swoop using machine learning? The data collected included lots of photos as the drones were landing. Their drones were already capable of pinpointing where to land, but with safety being critical to their business, Swoop Aero also wanted to equip their drones with the ability to land safely. So an onboard computer model, a computer vision model, now detects whether humans are present in the landing area, and the drone can choose to abort the landing if needed. After succeeding with safe landing, they are now combining computer vision with live streaming to diversify their services beyond medical deliveries. What that means is now they can patrol coastlines, support search and rescue efforts by automatically detecting swimmers in distress, and help with marine protection by detecting illegal fishing. The possibilities are quite endless when you're combining object detection with video footage. And now as demand's growing for their services, their networks are expanding massively around the world. And they're starting to also explore forecasting and optimization, just to make sure that they can operate those networks as efficiently as and as cost effectively as possible, while still ensuring critical supplies can be delivered in a timely manner. In terms of challenges, their main challenge, at least initially, was collecting data to train their custom models. In that safe landing scenario, we talked about the vision as the drone is descending into the landing area is very different to the vision you get from more common human detection models. So they had to source their own data for that. Also, many organizations call out integration challenges as being a big blocker when trying to productionize and operationalize their machine learning models. In Swoop's scenario, this is all even more challenging, given their solution required a custom computer vision model that needed to run on the edge. So that's an IoT device with limited processing power, operating in environments with limited or no internet connectivity. And of course, all of that requires some very specialized skills to bring it together. Speaking to Andrew Thomas, Chief Architect at Swoop, his advice is always start with off the shelf wherever possible, and this includes models and data sets if they're available. They actually started with an cloud-based AutoML product before going down the custom route. Invest in your data quality, irrespective of where you are on your journey, because your models are only as good as the data available to them. Contextual information about your data, so the metadata, can be useful as well. In their situation, altitude readings were very useful to them to help them understand and label their images. And lastly, stick with mainstream frameworks like TensorFlow. That provides greater hardware support and model choice. These platforms are continually being invested in and improved, so that can also help you future-proof your solution. Now, lastly, to Baltic, similar to Swoop Aero, they were looking to scale their business as much as possible. In their case, or one of the examples was device protection across Europe and Asia. They saw other industries using machine learning in a similar way. For example, computer vision to detect cracks and rocks, rock fractures, I should say, in mining, and thought that could be applied to their product. So they really saw it as an opportunity to speed up and automate the process of taking device protection insurance and also making claims. So with computer vision, a device such as a smartphone can quickly be assessed for damage, and all of this is done online and by the consumer. The fast and seamless experience helps with conversion, and because the device does not need to be examined by a human, there isn't the need to scale up the number of staff or centres. They're also using AI machine learning in other ways in their business, such as sentiment analysis to improve customer support. And lastly, as their business grows and expands, they're also exploring ways to detect suspicious behaviour and potential fraud in their network. Now, in terms of challenges, monitoring their models and ensuring performance has been a challenge for them. New smartphones, as we know, are released each year with different form factors. So the damage on a foldable Samsung will look different to the damage on an iPhone. And as they scale, both in the markets they operate in and then also as their team grows, they need to manage infrastructure in a cost-effective manner. For example, optimizing model training and inference while still ensuring latency and customer experience isn't compromised. And as their team grows, more and more models are being built and managed, so they've got to make sure that their teams can remain as productive as possible. And lastly, given they're operating in many geographical regions, this means they've also got to be on top of regulatory requirements. So, for example, GDPR, PII in Europe. So Dave Lynch, Melbourne-based group CTO, suggests and always advises his peers and people in this space to stay ahead and by having a bias for doing rather than overthinking. While they've established quite a successful product, they continue to always use machine learning across their business and experiment with new techniques and models to make their products as accurate and as user-friendly as possible. Secondly, machine learning isn't perfect, just like humans. So it's important to keep that in mind and provide some safety nets when needed. For example, when their models aren't confident with the prediction, depending on the threshold they set, they'll automatically send that to a human for review and allow a person to make that final judgment. And lastly, invest in cross-functional teams to create really great products and consumer or customer experiences. This is particularly important for consumer-facing products and features that are powered by machine learning, where the consumer themselves are actually interacting with the model. So in summary, 3 very different organisations using machine learning in varying ways to differentiate their products and services, all looking outward and inward for problems to solve, and with different challenges, including skill gaps, but all successfully navigating through that with the right mindset and approach. Back to you, Kirsty.
Thanks very much, Mark. Yeah, so I think we might do some questions now. We've got around 10 minutes left. So I know we've got a few questions on Slido, so we might get to those first. I'll ask Chris to read those out for us. Chris?
Yep, sure. So the first question we have is, did ML adoption vary by industry?
Okay, I can take that one. So no, well, yes, it probably does. I know that there are many surveys that have reported, but we actually collected data across 18 industries, and some of the sample sizes within those industries are so small, you can't really compare. We had hoped, I guess, compare industry to industry. We had hoped that with this much larger sample, we were going to get these pockets that we could look at. But, you know, I guess it's kind of a good thing that we had this nice spread across 18 industries, which means that there's a lot of diversity and representation from across the market within our industry. But no, we weren't able to make any, I guess, findings or observations about industry to industry. Although, I'm just talking out loud here, Mark, you could probably say, like, what are our most common use cases that we get in terms of like a consulting space? I know
it's Kirsty, it's actually quite varied, but what we're seeing a lot of more recently is document processing, intelligent document processing. So whether that be in financial services or in legal tech, lots of documents to be processed, automating that process, whether you're lifting content out, automatically categorizing, but taking some of that manual labor out is something we've seen a lot of out there. But I've got to say there's also lots of interest in just more generally just creating greater customer experiences. And that will look different in every industry in business.
Yeah. Great, thank you. I hope that answers that question. Don't forget, guys, if you wanted to go ahead and ask a question, you can use both the question and answer feature in Google Meet and the Slido. Chris, I think we've got a couple more. Do you want to go ahead and give us the next one?
Yeah, we've got a couple more in Slido. So the next one is, given Australian organisations are so heavily focused on security after the Optus and Medibank breaches, do you think security concerns will impact further ML take-up?
Oh.
I'll take that one. Yeah, thanks for the question. Look, there's two things going on here. One is the spending priority, and the other is the risk from ML of further privacy breaches. I think from a spending priority, certainly, as I'm sure the audience understands, machine learning runs on copious amounts of data, and if organisations have been accumulating data that involves personal information, they may suddenly have realised that they are quite exposed and at risk, and it could well divert spending to make sure that they've adequately protected their existing data. In terms of the impact on ML, on machine learning directly from privacy concerns, it's very rare that a machine learning model in its behaviour can reveal anything about individuals and their personal details. So I think the real risk is around the data that's being held, and that's in a way quite separate from machine learning. So organisations will make that judgment, I think, on how secure they feel with their data.
Thank you, Nigel. Thank you very much. Chris, have we got any more?
Yep, just one more on Slido. So do you expect more organisations to adopt ML next year in response to the economy? For example, efficiency, automation, that kind of thing. So I would assume reducing costs.
I think probably we can all weigh in on that one. So I did talk a little bit about what we think might happen, and I guess really what should happen. We do believe that organizations should be taking a closer look at machine learning in order to identify opportunities for workflow automation. It's a really, I guess, not easy, but it's something that has a huge amount of opportunity to deliver a great amount of benefit. And I think that because you can look at it from two sides, certainly probably the same model's not gonna, like, you're not gonna have one model or one application that's gonna deliver both workforce efficiency and revenue generating. But if you apply machine learning, I guess, successfully across your organization, you can achieve impacts in both those areas. So I think you can't say that it will, but definitely I think we here at DIS would say that organizations should be looking more closely at it as a lever that they can pull to deliver those improvements that they're looking for. Over to you, Mark and Nigel.
I think you've covered it mostly, Kirsty, to be honest. And, it was something that was a big focus last year, right? Survey, and I think it will be an increasing, I guess, channel for organisations to look internally for cost savings or efficiencies, right? Doing more with less, I guess, is a general theme that we're hearing out there, and looking for any efficiencies in your workflows, right? And really supporting your staff to be as efficient as possible, whether that through decision support, forecasting, optimizing what you do. There's a multitude of techniques that you employ internally that might actually either complement and augment what your staff are either doing, currently doing, or improve some of the decisions they're making as well.
Yeah. Yeah. Chris, I think that's it, don't you?
Yep, that's it for the questions.
Okay, well, I think we might finish there. Mark's just going to wrap up with a little bit of information about an offer that we've got if someone wants to talk more about how we can help them with machine learning. Over to you, Mark.
Thank you, Kirsty. So for those watching, we'd like to offer a complimentary workshop with our machine learning team to help you along your journey. There's a QR code down the right that you can scan for more information. So it doesn't matter if you haven't started identifying problems to solve, or you find it difficult to progress beyond your POCs at the moment, or even if you're at the mature end, as we described with Baltic, and are looking for some advice, I guess, around how to optimize your solutions or improve team productivity. We'd love to hear from you, understand your challenges, and hopefully help you take a step in the right direction in the future. Thank you.
Thanks, everyone. Thanks for joining us today.